Maybe part B will kind of lead you into why if this was truly our business, we wouldn't want to run it this way. I mean, think about it. What are you sitting at right now, right? You're sitting at a table? How many chairs are at your table? 4. You make 40 tables. Are 40 chairs going to be enough?
No.
Just one person at each table? You know what I'm saying? When you go buy a table at the store, you don't buy, it doesn't come with one chair. It comes with usually a set of chairs, right? So if you're manufacturing this, there might be one additional constraint that you want here, one additional condition. What would that be? Let's say 4 chairs per table at the least. So remember how we had all those constraints there? I'm going to write the constraints again. If we have 90x, this was profit, plus 25y. Help me out here. What were our constraints? We had
8x plus 2y.
Okay.
2x y less than or equal to 120.
And then x greater than or equals 0, y. Now let's look at this third. Well, it would actually be our 5th constraint. Okay, on top of this. Of course, we need to make more, 0 or more tables and 0 or more chairs. But if we want to have 4 chairs for every table at least, then how can I write that as an inequality? What if I said it this way? I want 4 chairs for every table. How would I write that? 4x plus y? Okay, x plus 4y, I'm hearing that. Oops, that's not an x. X plus 4y. What else? X plus y equals 5. I'm just writing down what I'm hearing.
What about, 4y equals x?
4y equals x. I'm just writing these down. We're going to talk about which of these are right. Any others?
Just the first one.
This one? But here, I need something in here, don't I? It needs to be an inequality. I asked you to think about the equals. Look, I'm going to make a table, okay? Let's say I make one table. So if x is 1, right, that's one table, what does y need to be?
4.
Y needs to be 4. What if I make 2 tables? Y needs to be what? 8. If I make 3 tables, y needs to be, what, 12? What is, I think you're right. Well, I don't know if I heard that right.
Like x is less than or equal to 4y? No?
I think you're almost there. You're almost there. Look at this one. Who said this one? Almost. Do you see what's wrong with it? Look, if x is 1, I need y to be 4. It's backwards. Look. Wait, other way. There we go. Sorry. Look at that right there. Okay, look at this right here.
Well, why?
What's that?
Why is it like
Okay, what is y? What is y? The number of chairs. You want to always make 4 chairs for every table. So if I make one table, 1 times 4 would be 4 chairs. If I make 2 tables, 4 times 2 would be 8 chairs. Make 3 tables, 4 times 3 would be 12 chairs. Understand? I need this to be an inequality, though. So I want, what, at least 4 chairs, right? So you want y to be bigger than or equal to, right? Because look, if they're equal, what if this is 5? Or I should do it the other way. You make 1 table. How many chairs? 4. Y needs to be bigger than 4 or equal to 4. So you can make 5 chairs. That's okay. Make sense? That last part B is a little tricky. But once we get this, we can throw it. Am I okay with you guys? So I can just put that over here, 4x less than or equal to y. So how would that, do you have a question? No? You still not happy with this?
Why is it 4x instead of 4y?
Okay, why is it not 4y?
because
Okay.
say if you had like 2 chairs, because chairs are wide. So it'd be 4 times 2 is 8. but then that'll be less than your tables, and you need more
Okay,
than your tables.
yeah, how many tables do you want me to make? Two. How many chairs do you think we should have for that? Okay, so you want X to be 2, right? And you agree with me that Y should be 8 or bigger, right? Let X be 2 right here. Let X be 2, and you would get 4Y less than or equal to 2. Divide both sides by 4, you get Y is less than 1/2. So according to this, which you're suggesting, or not suggesting, but you're asking why, the reason is because if you are going to make 2 tables, you are going to have to make less than half of a chair. That doesn't make sense. This one, though, if you make 2 tables, right, then this is going to be what, 8 less than or equal to Y? That means the number of chairs needs to be bigger than or equal to 8. That will work. Does that help clarify it? Yes.
So, I'm trying to find a shortcut, because I don't want to do all that crap. So can we just like,
Shortcut for what?
can
Like-
we just do like the 2 lines and then find the intersection point? Like if say, okay, you know how you do like 0 for X, find the Y, 0 for Y, find the X, and you plot those 2 points, but what if we just work out the 2 lines and then do like that, you know? And then we can plot our point.
What?
Is every time that the X are maximum, every time will it be like that point where they meet?
No.
Because in the last problem.
No, it won't. Yeah, sorry. Yeah, sometimes you get something like it says, hey, just make all tables, and that's your maximum profit. But that wouldn't make sense as a company again, right? But here is a shortcut, since we've done the problem already, is that we already have 4 of the restrictions, right? We already know what this looks like. All right, so we had, and I'll try and do this roughly here. One of them was up at 200, right? I remember that. And then it hit down here at what? And at 50. So we had one line that did this, right? We had that.
120
And then 120
I mean 60.
and 60, which was out here. And then we had the x-axis and the y-axis, right? And it was all focused in here, and we found that point 40, 40. Right? That's where we were. We now have to add this additional restriction on here. So let's first turn it into an equation. 4x equals y. Can you find me a point on that?
That'll be,
Okay. Y equals 4x. Let me write it the other way. Plus 0. So this is like y equals mx plus b. So what's your y-intercept? 0. So this point lives there, right? Maybe. And then up 4 over 4. Up 4 over 4, right? I'm sorry. Up 4 over 1 is what I meant to say. Up 4 over. So here, this is this one right here, right? Well, I'm trying to do this one. And so I go up 4 over 1, up 4 over 1. So where does it look like it's going to hit? Somewhere in here, right? So it's looking to me like it'll be something like that. Let's try a feasible region. I mean, sorry, which side of the line do we shade? Which side of this? So we have to pick a test point, right? You want, what do you want to test? What would you test? 0, we can test that, or 1, 0, doesn't matter. 1, 0? I'm going to test 1, 0. Where am I going to plug 1, 0 in? Into this. Let's try this. 4 times 1 less than or equal to 0. Yes or no? No, that's not true, which means shade the other side. Which means that the old feasible region was this whole thing, right? Now, my new feasible region, I have this additional restriction that I'm pointed inside here. So my feasible region is this. Understand? Which means I have a new corner point. And this one doesn't matter anymore, because it's not in my feasible region. How do you find that? It's the intersection of this line, which was which one over there? Which one was it? It was this one? I need to find the intersection of these two. Right here. So I need to set up a system of equations. I have 5 minutes. I can do it in 5 minutes. Yes, we have a new answer because our company, we sat down and we finally said, shit, it doesn't make sense to make 40 chairs and 40 tables. we need at least 4 chairs for every table. So we're rethinking everything, right? We're rethinking the whole process. And so now let's find the intersection. We have 2x plus y less than or equal to 120, and then 4x is less than y. You could do substitute. Oh, wait, hold on. We're making these equations. Pardon me. Just do a substitution. Like we already know what y is, right? Y is 4x. Just go up and rewrite that first one. 2x plus y is 4x, so 4x equals 120. 6x is 120, so x is 20. Once you know what x is, you know what y is, don't you? Let's go right in here, 20. So y is 80. So this is the point 20, 80. So now what we need to do is check our profit there. 20 tables, 80 chairs. So let's check our profit there. The profit at the point 2080. I know I'm working kind of fast through this last part, but should be, what was it, 90 times x plus 25 times 80. Someone do that for me? 3,800. So let's recap, okay? We're sitting at our business meeting, right? And I'm sitting there saying, you know what? We need to make 40 chairs and 40 tables. We will make a maximum profit of $4,600. That's my pitch. What's your pitch? Why am I ridiculous? Is this your pitch? Why? We're gonna make less money. $4,600 my way, $3,800 your way. You'll actually sell the tables. Yeah. You're never going to sell your 40-40, right? It's not practical, right? Have you ever gone into a store and bought 1 chair, 1 table? So this is why these business models are so important. I mean, it's not just all about the profit. If you can't sell your stuff, then there is no profit, right? This is the most profit you could possibly make, is if you did 40 and 40. That's the most, but you're never going to sell 40-40. So you have to start adding more and more constraints. And the more constraints you have, the better your business model is. All right, well, I guess that's all that was on here. You can do the other 2 examples. I hope this all made sense. I hope I don't see you again. No. I'll be back if she cancels again. I'll be back for the next section. Oh, I didn't send the YouTube video links to Kelly. I will do that today. I'll go back to my office. The others are already up there. I just need to send the links. Okay? All right.